Okay. Now we're going to do the same thing, finding the true or the new course to come to that will and how that will affect the vector triangles for all of the contacts, but we're going to do it on the Navy plot. And I'm going to show you why I like the Navy plot more. I think it's faster. Yeah, and I'm going to use the exact same process. So remember, same scenario. You found the situation here. You found that you're overtaking this contact and crossing this contact, and you're the giveaway for both, and you've got this one astern of you that isn't a risk yet, and you need to maneuver to starboard to pass clear of them. You tell your CO, not captain here, CO, whatever, and you would like, and they instruct you to give them a CPA of 2 miles. Sure, I don't know if that's realistic, but that's what they want. And we know, we're basing it off of M3 of contact C here. We know if we set up our DRM, we could get a new DRM that goes all the way out to here, and we could get a new DRM that goes all the way out to here. And we know that this is the correct one because this one would involve passing ahead of contact C. So we can't do that. In accordance with the rules, we have to do this one. So we're going to select that as our DRM. We draw it out like so. There's our new DRM. Now what we're going to do is we're going to move that to the vector triangle to represent the RM line of contact C. So remember, here's contact. Let me just move the triangle out of the way so I can see better. We've got contact A, A's M right here. We've got contact B's M right here. We've got contact C's M right here. So if this is the RM vector we want from contact C, we need to slide the RM over to C, and we draw it out in the opposite direction, like before, and we get this is the new RM, and you can see it's clearly parallel with the RM or with the DRM line we drew. But now this is the vector of it, not the projected track of it. Now we have to set this to be worth 15 knots, just like we did before. Remember though, in the Navy plot, we're not using the 1-to-1 scale because the center triangle here is always in the 5-to-1 scale. So we come here to measure out 15 knots. Oh, no, I'm sorry. We don't measure out anything yet because we don't know what the R prime is going to be. What we do know is that we are keeping a true speed of 15 knots. So wherever we go, it's going to have to remain on this third ring here. So if we had a compass, we could draw out, we could swing an arc all the way over and see where it intersects our new RM line. And we can see that it intersects it right there. So we would mark that as R prime. So this is R prime to M. So this is the new relative motion vector for contact C. And then we connect the dots between E and R prime to get a true course for us to follow. And it comes out to, in this case, 292. So 292, 293. Clearly, they're pretty close. So we have a new course of 292 to maneuver for contact C. How is this going to affect the other contacts? Well, this is actually a lot easier and faster to do because instead of having to remake the triangle in all 3 places, we now have an ER vector or an ER prime vector for our vector triangle that applies to all 3 of them. If this is our new ER, then RM of contact A is not this to this, it's now this to this. So we can just connect the dots for contact A from R prime to M, like that. And now we could slide this right over to M3 for contact A. See? Slide it over to M. It's just slid a little bit. God damn. Measure out R prime to M. Slide it over to M3. And you get that as the new vector for contact A. You can see it opened up just like it did in the other problem. And now we could do, if this is M for contact B all the way over here, you could connect the dots from R prime to B's M value. Get that as our new RM vector for contact B. We slide it over to M3 for contact B. We get it going way out to here. You can see the RM lines, or the DRMs for all of them, come out to be the same. We got the exact same information here. This is obviously a cluttered mess, and it's really hard to tell what's going on. But if you look really closely, you can see this is our original ER vector, and we get ERM for contact A here, and then after we maneuvered, we got ERM for contact A. For contact B, we had ERM as the original triangle, and then ERM as our new triangle. Then for contact C, we had ERM as our original, and now ERM as our new one. So if you, trust me, it's a lot easier to make sense of when you're doing it yourself because you knew what you drew. It's kind of harder when you're watching someone else do it, but you can see what's going on with all these triangles. And while it's more crowded than these having a separate triangle for each one, it's a lot faster because all you have to do is make one new RM line and you automatically get the information for all the others. I mean, if you had like 6 contacts, now that would be horrible. And at that point, you really shouldn't be doing a MoBoard for all 6 at once. But I wouldn't want to go and work on 3 different or 6 different vector triangles for all of them. I would just want to have all of that information in the center and maneuver once and see how it affects all of them instantaneously. I like this more. However, it comes out to accomplish the same goal.